In this video, I want to cover the three topics that we're going to be discussing in section 4.1 of the textbook. And there's like I said, there's three topics we're covering: ratios, rates, and proportions. So I'm going to start off with ratios and go from there. So definition, or ratio, is the quotient of two quantities. So this word quotient, this is another word for fraction. So a ratio is usually given, there's a few ways it could be given, but normally it's given as a fraction. So for example, for every 50 chicks raised, 3 of them die within the first 2 days. Okay. The ratio of the number of chicks that die to the number raised, so the number of chicks that die would be the 3, and the number raised would be the 50. So these are the two quantities that we're using in this ratio. So the ratio would be 3 to 50, or 3 over 50. And sometimes the ratio is given with a colon instead of a fraction. So this 3 colon 50 also means 3 to 50. Okay, so a ratio, it basically involves a fraction. And it not necessarily has to be in simplified form, and it doesn't necessarily have to contain units. It's just the ratio of two quantities. So for example, find the ratio of 5 to 6. So again, this word 2 means fraction. Okay, so the ratio of 5 to 6 would be 5 over 6, or we could write 5 colon 6. These three expressions mean the same thing. 5 to 6, 5 over 6, 5 colon 6. So this is just notation. And the ratio of 25.6 to 100, well, that would be 25.6 over 100, or 25.6 colon 100. Now again, this is not simplified. 25. If you have a fraction that also contains a decimal, that's not considered a simplified fraction. But a ratio doesn't necessarily have to be in simplified form. When you're doing your homework, though, it's I think 100% of the time you're going to have to express your ratio in simplified form. But just keep an eye on the directions and how they specifically state how to give your final answer. Another example: for every 5 people having a dog, 2 other people have a cat. So what is the ratio of dog owners to cat owners? Well, the dog owners would be the 5, the cat owners would be the 2. So we would say 5 over 2. The value that the quantity that comes first in the statement always goes on top, always goes in the numerator. So 5 over 2, or 5 colon 2. Okay, looks like I have the same problem twice, so we could ignore this one. Okay. Sometimes the ratio could be simplified. So for example, write the ratio 20 to 15 in fraction notation and then simplify. So this 20 to 15 here would be 20 over 15. So that's the unsimplified ratio. And since 20 is 5 times 4 and 15 is 5 times 3, they have this factor of 5 in common, so we could cancel that off, and we get the simplified ratio. So we call this an equivalent ratio, 4 over 3. So like I said, if a fraction contains a decimal, it's not considered in simplified form. So let's write the ratio of 3.6 to 5.2 in fraction notation, and then simplify it. So the unsimplified form would be 3.6 over 5.2. Now, to simplify this, well, we have to get rid of the decimals. And we could do that by multiplying by 10, basically moving the decimal point one place. So 10 on top, 10 on bottom. So basically we're multiplying by 1, because 10 over 10 equals 1. So that becomes 36 on top and 52 on the bottom. And these two numbers share some common factors. So we could definitely simplify the 36 over 52. 36, well, let's see. 36 is 4 times 9, and 52 is 4 times 13. So they have a factor of 4 in common. So we could cancel that off, and the simplified or equivalent ratio would be the 9 over 13. Okay, so this initial ratio is unsimplified, and this final equivalent ratio would be considered simplified. All right, so like I said, sometimes ratios will contain units and sometimes they won't. But in this example, a certain sports vehicle could go 414 miles on 18 gallons of gas. What is the ratio of miles to gallons? So we have miles on top to gallons on the bottom. Okay, so it looks like 414 miles on top and 18 miles on the bottom. And this could definitely be simplified for sure because they're both even numbers. But if we go to a calculator and do 414 and divide that by 18, we get 23. So that's 23 miles on top, 1 gallon on the bottom. We could also write this, well, 23 over 1 is 23. That's 23 miles per gallon. And normally this is written as mpg, miles per gallon. So 23 mpg. Now, this ratio here, this simplified ratio, 23 miles per 1 gallon, this is also called a rate. And the reason it's called a rate is because of this part. When the ratio contains units, so the miles and the gallons, so 23 miles per 1 gallon, when the ratio contains units, it's called a rate. And now a rate, so the rate of miles per gallon would be 23 miles per gallon, or 23 mpg. Now, a rate is always a ratio that contains some meaning. The numbers contain meaning, right? So that to be a rate, that there has to be units attached to the numbers. So our definition of rate, when a ratio, so it has to be a ratio first. So when we have a ratio, that is used to compare two different kinds of measure. So this word measure, this means it has units. Each number has units attached to it. We call it a rate. So for example, a student lifeguard working at a community pool earned $3,762 for working 12 weeks in one summer. What was the rate per week? So we're working with dollars and weeks. So those are the units involved in this ratio. Okay, so the number of dollars would be $3,762 and 12 weeks. And we want to always simplify our rates, or normally we divide the rate and give it as one single number. So the 3762 over 12, well, fraction means division. So what we want to do is divide 3,762 by 12. And again, this is a task for the calculator, but if we do 3762 and divide that by 12, we get 313.5. So that's $313.5 per 1 week. All right, so the way we express the rate, like I said, normally just one single number would be $313.5 per week. So that would be basically that would be the pay rate in this problem. All right, so we've talked about ratios. It's basically a ratio is a fraction. Sometimes that fraction contains units, sometimes it doesn't. Then we talked about rates. So we said, okay, well, if that ratio contains units, or if those numbers have like physical meaning, we call it a rate. And the third topic I want to discuss is proportions. Now, a proportion is basically a statement that is saying two ratios are equal to each other. And in that case, we say they're proportional. So the ratio of the numbers 3 and 2 and the ratio of the numbers 6 and 4 could both be given as a fraction, 3 over 2, 6 over 4. But since those two fractions are equal to each other, we say that these two ratios are proportional. And anytime you have basically a fraction equaling a fraction, we call that statement or that equation, we call that a proportion. And just like we could use the word 2 with a ratio, sometimes, it's not very common, but sometimes we could do the same with a proportion. So we would say 3 is to 2 as 6 is to 4. That's what this says down here. That's not very common. Normally, if we're using a proportion, we're using an equation. So there's an equal sign and there's two fractions involved. And we started off here with two fractions that were proportional, but if you don't know if they're proportional or not, you could basically set up the proportion. So in this case, example, determine whether the numbers 2 and 4 are proportional to 5 and 10. So what we would do is set up the first ratio, 2 over 4, and say, well, is that equal to 5 over 10? And anytime we're working with a proportion, to get rid of the fractions, what we could do is calculate what's called the cross product, or sometimes it's referred to as cross multiplying. So we multiply across diagonally. So 2 times 10 equals 20. 4 times 5 equals 20. Well, they both equal 20, so yes. The answer is yes. These two ratios are proportional. And if we got different numbers here, then the answer would be no, they're not proportional. So for example, determine whether the 6 and 7 are proportional to 8 and 9. So we do the same thing. Set up the ratio 6 over 7 and set that equal to 8 over 9. And basically we're asking, is this a true statement? So to test that, we calculate the cross products. We cross multiply. So 6 times 9, well, that's 54. And 8 times 7, well, that's 56. So we have two different numbers here, so no. These two ratios are not proportional because we have a false statement when we set up the proportion. Now, one thing we're going to be doing throughout the rest of this chapter is what's called solving proportions. And so when we're solving proportions, the A, the C, and the D in this case are numbers that we know. And the X, well, that's the variable. We don't know what X is. And we're basically wanting to solve for X. And we do the same thing. We cross multiply. We calculate the cross products, and we then solve for X. And it turns out to always be a two-step process. So in this case, solve for X, or solve this proportion for X. So let me just rewrite it a little bit bigger down here. X over 8 is equal to 6 over 5. So if we wanted to solve for X, let's start off by cross multiplying, calculating the cross product. So X times 5, that would be 5X. And the other one, 6 times 8, is 48. So step one, cross multiply. You're always going to get a multiple of x. And now this is 5x means 5 times x, multiplication. So to undo that or reverse that, or you think about this in terms of getting rid of the 5, we could do the opposite. The opposite of times 5 is divide by 5. So we could divide both sides by 5 because on the left-hand side, these two operations cancel. Taking a number and multiplying by 5 and then dividing by 5, those two operations cancel. Or you could think about it, 5 over 5 is equal to 1. So we get x is equal to 48 over 5. So we've solved for x. In this case, the directions then state write a mixed number. So 48 over 5, that is 9 and 3 over 5. So remember, to convert a fraction to a mixed number, we divide using long division because the calculators don't generally work with mixed numbers. So 48 divided by 5, 5 goes in 9 times. That's 45. So we have a remainder of 3. So there's the 9 whole times. There's the 9 with the remainder of 3 out of 5. So there's the 3 over 5 part. And let's just do one more example. Let's solve for y. The variable could be anywhere. There's 4 positions on the top on the left, bottom on the left, top on the right, bottom on the right. So it doesn't matter where it is. So we're going to do the same thing. 2.1 over 3.6 is equal to y over 1.8. So we start off, we cross multiply. Anytime we're solving a proportion, and this, like I said, this is something we're going to be doing a lot of in the sections to come, which we'll talk about Wednesday and also next week. So we'll multiply 2.1 times 1.8 and then 3.6 times y. Okay, so 3.6 times y, that's, here's the blue, 3.6y. And then we're doing 2.1 times 1.8, so that's 3.78, and that's just according to the calculator, 2.1 times 1.8. So step 1, cross products, and step 2, divide by that factor in front of the y. We want to get rid of the 3.6 times on the left-hand side. So we'll divide by 3.6, divide by 3.6. And the directions here are write the, don't want red. The directions here are write the decimal notation for the answer. So we have to basically take this, pop it into the calculator. 3.78 divided by 3.6. So on the left-hand side, the 3.6's cancel. We have y by itself. And on the right, if we divide these two numbers in the calculator, we will get 1.05. Okay, so that's the process of solving a proportion. Okay, so that about does it for section 4.1. So now that you've watched this lecture video, I have some practice problems that I would like you to go through, and just a worksheet with 7 problems and 7 individual videos. And you could find them in the email I sent to the class or posted on my ePortfolio. But you definitely want to watch all 7 of those videos. That's not optional. You have to watch those 7 videos before starting the 4.1 homework. All right, that does it for this video, and you've got 7 short videos because, like I said, each video is just one single problem. All right, that does it for now.